Hi everyone, welcome to the what, when, and why of Python, especially for Python beginners. So happy you're here and excited for you to take this journey into Python, learning and growing in the language. Be sure to pay attention in the deck. I'll tell you how to download the slides. You can always have those as reference. And this is one way I really love to learn and grow, is I like to have a reference to come back to and not just skip through a video. If you find value in the content and I help you out here, please subscribe to the channel and please drop me a message saying that you did subscribe and I will respond to your message. Let's go ahead and kick it off with Python Lesson 1. Here's going to be our agenda for this lesson. We're going to explain the what, why, and when of Python, talk about the interpreter, Python modules, variables, values, and types, objects, keywords, strings, indexing, and slicing. And throughout the presentation, we'll take a break and do some labs, and then we'll come back to the presentation. So this really is similar to any other kind of class you just kind of watch and go through. What is Python? It's a high-level interpreted programming language, dynamically typed with an emphasis on code readability, super easy to read. Supports multiple programming paradigms, procedural, object-oriented, and functional programming. It has a comprehensive list of libraries that covers many areas of the software development. And then look how old it is, 1991. Been around for a while. Why do you use Python? Well, as we said before, readability. Clean syntax makes code easy to read and write. Versatility. It can be used for web development, data analysis, AI, computing, scientific, automation, and more. Scripting, automation is what I love to use it for. It has extensive libraries, a library for almost everything. Popular ones are like Django for web development, Pandas, data analysis, TensorFlow, machine learning, and many, many more. It has a huge amount of community support. Here are some of the SaaS products that I know about. GitHub, Jira, Slack, Trello. These are Python wrappers. Stripe, Salesforce, Dropbox, Zendesk, HubSpot, QuickBooks, Shopify, Square. It basically, if you look hard enough, there is probably a Python wrapper for any popular SaaS utility or service that you use. It's cross-platform, super powerful because you can write Python on any machine, Windows, Mac, Linux, and it will run on the other machine. Super powerful. Integration easily integrates with other languages like C, C++, Java, etc. It has and other RESTful services. Productivity, rapid development capabilities, easy to prototype, easy to gen stuff up and just play with things, and we'll get into that in a bit. When do you use Python? Web development, data analysis, machine learning, automation, which is my favorite, scientific computing, education, back-end development, IoT of things. I really love using Python when you're able to combine basically a knowledge set that you have now, whatever profession you're in now, you can actually use Python to build a little tool or script or automation thing that applies to your particular domain, your expertise. So really you use programming, you learn programming to use it as kind of like your secret weapon. And that secret weapon, you can apply it to your current domain. That's where I think the real sweet spot here is for Python. The Python interpreter reads the Python script. It interprets the lines, converts it to bytecode, and is able to execute. It's run on the Python virtual machine, the PVM. This is the bytecode it's able to execute. And then that PVM is what is actually running the code, and that's been written for all these different architectures like Mac OS, Linux, ARM, you name it. The Python interpreter can be in interactive mode. That's what we're going to play with. That's what we're going to do. So we can just issue commands, and we'll see results. And you can play around with it right in the interpreter, right in the shell. Let's pop over to our first lab, Python interpreter. First thing we're going to do here is actually install the Python interpreter. If you are on Windows, you're going to have to, this is going to be a manual step. So come here to install Python Windows and Google, download Python. You'll get the latest binary from Windows and go ahead and install that. Walk through the installation, pretty straightforward. If you're on a Mac like I am, it's already installed. So just come here to your favorite terminal and type Python 3. What you're going to see is what version you're running. Python 3.11.4, when it was compiled. So this was in July. The C compiler, Clang compiler 14.00, and it was made for Darwin. Now, the very first thing you must do anytime you learn a new programming language is the sacred hello world. If you do not do this, the programming language gods will be mad at you. So please do that. It's a very fun thing to do. Now, when you want to exit the interpreter, you actually have to call a function, exit. Let's pop back in. First thing I'm going to do here in the interpreter is just show you some basic arithmetic. So 5 plus 3, 8, 10 times 10. Another thing you can do is, we're going to get into this later, but assign variables. Something you can do here, you'll get errors in the interpreter if you do something wrong. So print some number. Okay, you get a traceback error, and it's telling you what line that it tracebacked on because some number has not been defined as a variable. Python modules. What's a Python module? It's just a file that contains Python code. It defines functions, classes, variables, also includes runnable code. What's the purpose? Modules are used to organize and reuse code, enabling modular programming and separation. Usually the file extensions .py, that's how I've done them. You can import one module from another module. Like in this example, you're going to, in your module that you're writing, you can import the math module. And then you can use functions that are available in that module. So math.square root is defined in math. You import it and you can just use it. Or you can do this other syntax, from math import square root only, as this example right here. Let's pop into another lab, which we're going to play with the dir and the help function, these modules, and show you a little more there. Let's play with a module. Let's import our first module. So import math. That is the math module. And you may be wondering, well, what functions can we use with math? What are defined in math? Well, let's look at the dir command. The dir on math will list all these great functions that the math module has. So pal, pi, prod, radians. Let's play with one here, the square root. So math dot. What's really neat here is you can do tab completion. So math dot square root tab will give you the square root. So math dot square root of 4 is 2. You can also do this another way. So let's exit out of this. Let's come back to our interpreter. Let's import. So you can also do it this way. You can do from math import square root. If you do it that way, then you can just straight up call square root without calling math dot square root. In fact, if you do that now, you'll get an error. Yep, trace back, because it doesn't know what math dot square root is. It knows only what square root is. Next command here is the help. Actually, let's import all of math. Okay, now let's use the help command. So help will give you some documentation of the actual library. You can see here when you did help, and you get some really great developer documentation on what math does. You can call help on just about anything. So help print. There you go. What does print do? And hit Q to exit and get out of that. Python variables, they are reserved memory location to store values, acting as a reference to data. So something important here is that you must start with a letter, A to Z, or capital A to Z, or underscore. Cannot start it with a number, 0 to 9. Can contain letters, numbers, and underscores after, but they just can't start with the letters. With the numbers. Variable names are case sensitive. Age, you see there, and capital age. These are all different. This may confuse you a bit if you're more used to Windows, where it's kind of case insensitive. Assignment. So variables are created through assignment, the equal, obviously. So here x equals 5. And then you have dynamic typing. So what that means is you don't have to say, hey, x is an integer and it equals 5. In other languages, you have to do that, like in the C language, int x would equal 5. But you don't have to do that here in Python. You would do something like this. Int x equals 5. That's what it would be in the C language. You can reassign x. So x can equal hello, a string. It was an integer, now it's a string. And you can do multiple assignments at once. So A, B, C equals 5, 3.2, and hello. So A would be 5, B, 3.2, a float, C, hello, a string. Let's play with variables in a lab. Let's define x equals 5. And now we want to print x. We get 5. X, you can just type x as well. We can do x plus 4, 9. Let's set that to an answer. X plus 4. Print the answer. We can use print or we can just type answer. If we do dir, it will actually tell us what has been defined in our interpreter thus far. So you see answer and x. Let me make this a little bigger. Has been defined. So ants x, because we've defined them here. Let's do multiple assignment here. A, B, C equals 5, 3.2, and hello, a string. So what do you think C is? Yep, string. You can print. Super easy and simple. We also said that you cannot start a variable with a number. Let's actually try to. 1. Okay, there you go. It immediately stops you. Invalid decimal literal. You cannot do this. Data types. What are the data types in Python? Integers, floats. These are decimal numbers. Strings are text. One of my favorite things about Python is the strings and how, all the cool things you can do with strings. Messing with strings in the C is just a total nightmare. So super, super awesome strings in Python. Lists, very helpful. Or arrays. If you're coming from another language, that's kind of like arrays. Tuples, immutable ordered collections. Can't change them. Dictionaries, key value pairs, sets, unordered collections, and then booleans, true or false. What's an object? In Python, everything is an object. Every value in Python, a number, string, function, class, etc., is stored in memory as an object. Each object has a unique ID, and you can actually retrieve it with this ID, with this method here. The content data that the object represents, you can get that with type. And so here the type int stir for string or list or dictionary, and you can always do type and then your variable x, and it would print what that is. Here are immutable types. These cannot be changed after you make them. Integers, strings, tuples. Mutable types, objects that can be modified after you make them. Lists, dictionaries, and sets. Objects have a reference count. The number of references to the object, once that reaches 0, it will be deleted, gets picked up by the garbage collector. Objects have methods. So for example, in the string object, you can call .upper or .split. This converts it to uppercase. This would split the string. And then an object also has attributes. So for example, if you defined your own object, you could give it like a name or an age. So if you had an object like person, and the person would have a name or an age, these are attributes of that object that you define. Keywords. Keywords are reserved words in Python that have a predefined meaning, so you cannot use these keywords as your own variable name. They're used to define the structure and flow of a Python program. If you're using an IDE like VS Code, those words will show up in different colors so you know that they're keywords. They're immutable, can't be altered, and case sensitive. So true, capital T, is a keyword, but lowercase true is not. I don't use that. So yeah, that would be confusing. Keyword examples, a lot of them here. If else, if, while, for, break. I won't read all these. Class, def defines a function, true, false, none, lambda, yield, raise, with, async, await. All these are keywords. Strings. One of my favorite things about Python. A string in Python is a sequence of characters enclosed within a single quote, a double quote, or triple quote, or these triple double quotes. They're immutable. Once you create them, they can't be changed. Indexing. Oh, it's super easy to index a string. So if you had a string here called stir, and you only wanted the first character, you would just do stir bracket 0, ending bracket, and that would be the first character. Super easy to get to split off your strings. You can slice these things up and slice and dice them however you want. So this string here, you could just grab the first index 1 to 3 just by doing this. 1 colon 4 would give you 1, 2, and 3. We'll look at some examples of this in our lab. Escape sequences, backslash, carriage return for a new line. You can concatenate them, so you can say hello plus world, you get hello world. And then you can like do this weird kind of math on them. So the capital A times 3 really results in triple A. Strings continued. So the len, that's the length. You can call that function and it'll tell you the number of characters in that string. You've got built-in methods, upper, lower, split, replace, find, strip. We're going to play with these in our lab. You've got if you want to do multi-line strings, you have to use these triple quotes or triple single quotes in order to span over the multiple lines. If you were in the editor, you would see that you'd be getting an error if you didn't do this. And then you can format the strings. So if you had a variable that you wanted, you want to build up that string dynamically, you would do these f strings, and we can also play with that in the lab. Let's pop over to the lab for strings. Let's define our strings here. Name equals my name, Jared. We can do length on the name, 5. Let's do another name, name 2, Sam. Now we can do things like this, name plus name 2, Jared Sam. Or we could do some cool stuff like this, new, let's do a new variable, new name equals name plus, and then a space in between, and then plus name 2. New name, and then it put a space in between because we told it to put a space here. So you can add strings, you can do all really great things with names. So let's take this name here, and if we want the first character, we do this, name of 0, because that's element 0. If you think of a string as a storage space for, a storage space is just kind of an array, it's a list. Think of it that way, and the first element is 0. So here's another way to look at it. Let me pull this over. So J is element 0, A1, R2, E3, and then 4D. There's 1, 2, 3, 4, 5 elements total, but we start indexing at 0. That is the way it is in most programming languages. What else can we do with strings? These cool little built-in functions. Actually, let's do a dir on name. And then you can see all of these kind of cool built-in functions. So count, lower, split, rjust, rindex, rfind. You may be wondering, well, what in the world do those things do? Remember, we can do help on name.upper. And it tells you, return a copy of the string converted to uppercase. Let's try that. Remember, we can use tab complete. There you go. Let's do split, but before we need to do split, we need to actually make a bigger string. So let's do this for a sentence equals Jared is home today for the holidays. Okay, we can print that. There's the string. Really love the split command. You'll be using it a lot. It makes Python super easy to use and super powerful. So let's do this. Let's just do sentence dot split, and let's split this string on the spaces. We didn't put that into a variable, so let's do answer. Okay, now answer is an array. It's a list, and every element is boom, 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 is every word that was there. It's kind of a tricky question. If you want the first element of this word, what would you do? You would do this: answer bracket 1. So answer bracket 1 is going to, so here's the 0th place, here's the 1th place, and then 0 is going to give you I, because you've indexed into this array, and then you indexed into this list. And there you go, there's I. Let's do find. Find is pretty helpful. So sentence dot find, and we want to find 4. And there it is. It told you it's in the 20th place. So now we can do sentence 20. There you go. There's the F. It's telling you the location of where 4 started. Strip. Strip is really helpful, especially when you're like scraping and pulling in lots of data and you've got spaces on one end or the other. So let's do another sentence here. And let's put a bunch of spaces on the front. Hi there. And go now. Doesn't make any sense, but it'll work. So there it is. You got this weird thing there going on. So if we use strip, super helpful. Let's try it. It'll strip off the white spaces on the front and the back. There you go. Stripped it down on both the left and the right. If you only wanted to do it left or right, there's also special functions for that. Indexing and slicing. Basic slicing. Extract characters from 2 to 4. You do it this way. Give it the first index up to the ending. This does not include 5. Without start or end index, get all the characters from 2 to the end, so then you don't give it a number. So 2 colon and just drop it. It'll go all the way to the end. Get all the characters from the beginning. You don't give it as a beginning here. And get all the characters of the string. Don't know why you do that. I would just say your variable equals that string, but that's how you do that. You can do this weird negative indexing. Get the last character. So you start subtracting from the last character basically backward. So go to the end and then -1. Get the last 3. Same idea. You start counting from the end backwards. Step, stride, and slicing. So get every second character from the string. I haven't really done this much, but you can do it right there. You can reverse a string this way. It's kind of neat. Skip the first 3 characters and fetch the rest. That's how you do that. The middle section. Okay, kind of obvious. And then using slicing with data structures. So for list, you could do it this way. Let's pop into our indexing and slicing lab. Let's now look at indexing and slicing. So let's get our first string here. Jared was home today. And now let's actually grab it from the back using -1. So that's why it grabbed the last character, because it's counting from the back. As you saw earlier, this was the first element from the front. And remember that we start indexing at 0 and not at 1. What if you wanted to get all the characters from 2 and the rest? it would start at the third element, 2, remember, 0, 1, 2, so that's the R, and then the colon says get the rest. And if we do that on the reverse side, we can do -3 and then get the rest of that. So it counted back 1, 2, 3 and then gave you the rest. We can also do things like pull out the middle, 3 to 6. And there you go. And for a copy of this PDF, just go to github.com, Jared Craze, Crazecast, blob main Python, Python lesson1.pdf. You can download it right there. And this is the home of all of my Crazecast material. I hope you really enjoyed this lesson. I hope you're able to get through it, and leave me any comments if you have any. Please subscribe and check out other things on my channel. If you have any comments, let me know. I'd love to know how to make this better. Thanks.